the last thing that I want to talk about today is the GIS research process. And so this is going to segue into a discussion of an introduction of Lab 3 quite nicely. So we'll work through the whole research process pretty well in Lab 3. So the process is essentially 6 steps that starts with framing your problem, then identifying and acquiring the data you need, preparing that data, doing the actual geospatial analysis, creating maps and reports, and then sharing or publishing those results, which oftentimes leads back into another research process. So step 1 is to frame the problem. What do you want to accomplish, and what are the problems and or questions you're looking to address? You want to think about the scope. So what tasks do you need to do? What are the data you're going to need, the time frame that you have? Is it focused on a specific region, group, or phenomena? What products are going to be needed at the end? You want to think about the scale that you're focusing on. Is it international, national, city? Is it down to the family or individual scale? What stakeholders are involved and at what scales, and then the type of information you're going to need. Is it going to be quantitative or qualitative? What are you going to end up producing? So once you've framed the problem, you want to define the project scope. So you want to delineate a set of boundaries for your area of interest, whether that's a municipal boundary or something like that. The point of this is to reduce the area to eliminate unnecessary areas or problematic areas or places that aren't of interest to the project. The narrower focus is usually better as it allows you to pay closer attention to the essence of the project. And so this might follow existing boundaries, or you might need to create your own. Then you can identify and acquire the data you need. So you start by thinking of possible data sources. Some considerations might include what format is your data going to take? Is it going to be raster or vector? Tables, charts, are there pre-existing maps? Are you going to have to do interviews, etc.? Then think about where you're going to find the data. Is this going to be government sources, libraries, open databases, volunteers? Are you going to collect it yourself? How much is it going to cost? Most data sources, unfortunately, aren't free, especially if you have to collect it yourself. That said, there are lots of freely available open data libraries. So some of the data I've introduced so far is freely available to anybody, but some of the data that we're working with, like the census data analyzer that we're going to use today, is only free if you're a member of an institution like UBC or something. And so UBC pays for a subscription to this data source, and then you as a student can use it. You're going to have to think about how long it's going to take to acquire it. So today, the data won't take very long to acquire. You just wait a little while for you to get an email download. But if you're physically going out and collecting the data, it can take months. Right? So the fieldwork for my PhD thesis took 4 months to get all the data. Then you can prepare your data. So you get, generally when you download data or you acquire data, you get more than you need. So you have to extract the necessary data from a larger data set. So this reduces the size and manages it so it's easier to use. You might have to reproject to matching coordinates. You might have to convert between raster or vector data types. You might have to do some sort of data classification, as we did in Lab 2, where you classified the NDVI image. You might have to update or edit existing data so it's usable or readable in a different format. So for instance, in this lab, we're going to convert from a polyline to a polygon. You might have to correct for errors, or you might have to create new input data. You might have to create new features, or you might have to convert data into spatial data. So if you've got like tabular data that's just like CSV file with XY coordinates, like we're going to get in this lab, you'll have to convert that to a spatial data format. And then you can do the geospatial analysis. So are you going to do overlay analysis, like what we talked about on Tuesday? You're going to do distance analysis, determine proximity or distance between features. You're going to do map algebra, so raster overlay. We haven't talked about that yet, but I'll get into a bit of raster overlay in the coming weeks. Then you can generate maps and reports. So it's time to turn the work that you did into information and knowledge that can be shared with others. So you generate maps and reports to highlight your finding. This might mean maps or images, graphics, tables, the visualization of your own process, like a flow chart of your workflow. We're going to be using something called Model Builder this week, and you can actually use that to create a flow chart of your work. So you can share it with your peers through articles or published paper. You can share it with the public through books or TV interviews, public reports, etc., or social media. So sharing and publishing the results often leads to new research, as most research often produces more questions than it ends up answering. So it's sort of a cyclical process.